Doc here with the physics tutorial on the rainbow for Physics 101, Light and Visual Phenomena. Here's a nice picture of a rainbow, and we're going to try to understand here the rainbow, the primary rainbow, and a secondary rainbow, which we'll see shortly, that exists. And we'll do this first by looking at a drop of water and white light hitting the drop. Now, white light will hit somewhere between the center and the top for the primary rainbow. This gives you a nice refraction and a reflection and a refraction to get the light coming back to us. Notice that our position will be here with the sunlight to our left, like behind our heads. When you look at the red light bends less, does the same sort of thing. I neglect here some reflection that takes place there. I neglect some escaping of the light here due to the refraction bending away from the normal, since we're not exceeding the critical angle, and I ignore here some reflection that goes on there. I'm interested in the light that comes out the bottom of the drop. So red does everything to a lesser degree, blue bends more, and you find that the blue goes over your head for this upper drop, and that means that the drops that are lower, see, if my eye were to go higher here, I would catch next the red, orange, yellow, green, and blue, and violet. So these are going to get to my eye by drops that are lower. So a lower drop will have the same effect as me going up. So if I were to go up, I would catch a yellow, but if the drop is lower, then it's the same effect, and I would get the yellow. So you have to look at this kind of analysis where the drops near the top are the red because the blue is going over your head, and then when you get lower and lower, then you can catch the other colors, and what happens then when you catch, for example, the blue, the red is going below your eye. You see, when you're catching the blue because of a lower drop, the red is then too low and misses you. So you need this diagram plus the droplet diagram, and that gives you the rainbow. Here it explains that red is on top, blue is on the bottom, and your angle is about 40 degrees, a spread of about 40, from 40 to 42, it's 2 degree spread. And there you have it, a cup of coffee found at the end of the rainbow, and that's the primary rainbow. For the secondary rainbow, the light actually hits a little bit lower. So when light's hitting the droplet, you're getting simultaneously primary and secondary rainbows, but for different people. Say, so everyone sees their own rainbow depending on where you're standing and where the droplets are in the sky for you. So here, the blue light bends toward the normal. It reflects once, reflects twice, and then bends away from the normal. And red does it to a lesser degree, blue does it more. And what happens here is that the red misses my eye, so that the blue is on top, and the lower drops will give me the other colors, and the lowest drop will give me the red, in which case the blue will be too low. So in this case we have a reversal, and notice that because of the two reflections we have a dimmer rainbow. So here you have it, where you have the red on top for the primary, and it's brighter, and the red on the bottom for the secondary, and a dimmer rainbow. And that's a summary of rainbows, where perhaps we can add one more thing, and that when you go to the secondary rainbow, you're looking at an angle that's greater than 40, around 50 or so. And here it says the secondary rainbow is 50 for red and 54 for blue. True or false? That would be true.